We now have a good understanding of how we calculate the gradient of cost with respect to model parameters. I want to show you a situation where that holds true even if we're chaining together thousands of partial derivatives. So backpropagation is an application of the chain rule of partial derivatives of cost with respect to model parameters, where we have thousands of functions chained together, thousands, potentially that many, of partial derivatives that we calculate, that we chain together so that we can calculate cost with respect to millions or potentially billions of model parameters in a single model. So backpropagation is used in artificial neural networks. So here's an example of an artificial neural network in a high-level schematic. It has many layers where in each layer we have each one of these circles represents an artificial neuron. And so here we have 1, 2, 3, 4 layers of artificial neurons networked together. And if we have many of these layers, so 5 or more of these layers, we call that a deep neural network or a deep learning architecture. And we can have thousands of these layers in some modern deep learning architectures. And there's millions of parameters to be trained by our training data in order to try to minimize cost. So in order for this to work, in the same way that we've been talking about, we can grab batches of training data from all of our training data, and then so our inputs, our batches of training inputs, we can pass those as inputs into our model, and the information flows in the forward pass, in forward propagation, through all of the layers of our deep learning model, which again could be thousands of layers. Here I only have 4 illustrated. And at the end of that long, deep forward pass, our model gives a prediction, a y-hat value, as to what it should be outputting given the inputs that came in on the left side here. And just as we did before in our 4-step machine learning process, where step 1 is the forward pass, then step 2 is this comparison of the predicted y value versus the true y value. And that gives us our cost C. And then in step 3, we have what's called backpropagation, which is just this same chain rule, this calculation of the partial derivative of cost, where we use the chain rule to go back all the way through all of the layers of our deep learning architecture. And within this architecture, we have different kinds of parameters called weights and biases. There could be millions of these parameters in the model, but the principles are still the same. This use of the chain rule of partial derivatives to calculate the gradient of cost C with respect to all of those millions of model parameters. That same principle allows us to use gradient descent to adjust all of those millions of parameters, W and B, gently in the direction of lower cost. So again, we're not digging into deep learning theory here. That isn't the point, but I just wanted to introduce this term backpropagation and give you a sense of how cool it is that this chain rule of partial derivatives can be so incredibly powerful.